Now, an accuracy of 100% on the training data and of 93% about on the test data does indicate that the model is overfitting, and we want to look at some regularization techniques that we can use. So, when you get an accuracy of 1.0, it's not that you need more epochs here, right? Or even like necessarily more hidden layers. Maybe you could get away with less hidden layers, okay? That could be something to try, but I think we want to look at some regularization techniques either way, because once you achieve that 1.0, that's an ideal setup. And the bigger question is, yeah, but what can I do to kind of like regularize, right? Prevent overfitting, okay? So some different things. One of them is called a dropout layer. Now to do a dropout layer, you're going to need to import it first. So if you go up to dints, because it's under layers, okay, it's its own layer, you can do a dropout layer. So this is a regularization technique. What dropout does is it gives the percentage of each node dropping out, right? Because if you drop it out, then if it can't go forward, then again, this is kind of like XGBoost with the smaller decision trees. You have to do more generalization, okay? It's not as like precise. So let's just try one, okay? So add dropout layer, because we're fine tuning keras. This is exciting. So model.add, and then you put in, kind of like you did with dints, right? You put in dropout. And then inside the parentheses, it's the percentage. I tell you that 20% is standard. I think I'm just going to go with that. I mean, if we've got 40, 40 nodes, that's a lot. We've got 40 twice here. So should we do it twice? I don't know. I mean, one thing you could do is try it once. Let's try it once and see if it makes a difference. Although, the big question is where should we try it, right? Because if you're going to a larger number of nodes, maybe we should do it the second time. And again, I don't know, experimentation. I'm just going to leave it there and try it. Let's see what happens. Let's see if it is actually affected. So you can just run this big cell now with all the keras code. And you can see it's moving up more slowly, right? It's not like rushing out to 100. And interestingly, let's see what the test set is. Look at that. The test set is a little better. So it generalized a little better. And it actually overfit even better because it didn't reach 100%. Let's try a second one. Pretty cool, right? It's a cool technique. So we'll go after the 40. You don't want to drop out any of the 10, right? At the very end. But you can drop out, right, after that first group. I don't think you want to drop out any columns either, but you could try that. Okay, so we've got 2 add dropouts. Let's see what happens. I'm kind of curious. And what we're doing here, again, we're experimenting. We're trying techniques. We're learning new things. We're experimenting. So we're still getting a high accuracy, not quite as high. And we could use more epochs. More epochs could be helpful here. And look at that, got a little better. So let's actually shift to 100 epochs. Right? Why? Because it didn't reach 100%. Can they both go up together? Let's see. You can see those like 1.00s and they disappear. I'm not sure if that's like they're starting at that and they change. Okay, it looks like no real gains by going up to 100 epochs. So let me jump to a next natural question, which is, but what about this number of epochs thing? Are we just always going to like guess like 50, 100? No, we're actually going to change that right now. There's a cool technique called early stopping. And what we can do is set something up that says, you know what? If we see no improvement after n epochs, we're just going to stop it. And then characters should go back and take the high score for you. So that's kind of ideal. Well, we can do that. That's called early stopping. Very cool. It's you got to use it with deep learning. So how do we get that in there? Well, if you go up, it's another import. So it's called a callback. So from keras.callbacks, okay, import early stopping. And then to get it in there, you can define it after you compile it. So I think we're gonna split these out now. Compile model. Go ahead and split these into 3 columns on your own. We're gonna make some changes. Evaluate model. Fit model. And now what I want to do is set up early stopping. Okay, so you call it typically an early stopping monitor. Got a nice little standard name there. Self-explanatory. Coding, when you're coding well, your variables should be clear what they do. Okay, right? Why is this clear? Because it's monitoring the early stopping. It's variable. And what should it be equal to? Well, look, when you import something to use it, that's what you set it equal to, okay? So early stopping, there it is, right? And then what goes in parentheses? So it's actually called the patience. So the patience was then how many rounds do you want to, how many epochs do you want to wait before you don't see improvement to stop it? Like if you say, well, I'm just going to go with 2, what can go up and down? You're not going to get very far. You have more than 2. I see 10, 100, 15. I don't know. I'm going to try 15. Why 15? I don't know, because you could actually not see improvements for 10 and then suddenly have it. 10's probably fine here. What the heck? We could try 12. I mean, it's not really... I think I wouldn't pick too large because we don't want to wait too long. But if you increase this, maybe I'll just keep it at 10. Then this can go way up. Like, hey, put it to 1,000, right? Why? Because if it's continuing to make improvements, then you're going to get better scores, right? Once it doesn't improve for 10 rounds, it's going to stop. So the point is your epoch should be really high. You're expecting early stopping to actually stop the model, stop the number of epochs, okay? And then the other thing is we need to put it in here. Okay, so note that we set it up, but it's not, see, like, okay, we defined it here, but it hasn't entered the model, right? Right, model.compile, that's entered the model. Model.fit, that enters the model. Model.evaluate, that enters the model. So you got to put the early stopping monitor in the model. So model.fit, and then you could say callbacks equal bracket early stopping monitor. Okay. Pretty cool. And then it's going to, what does it do? It's going to do what I told you. It's going to stop when there's been no improvement for 10 epochs. And it'll go back 10 and say, here's your best score. Okay. So this also prevents, we looked at some graphs where if you keep going, your model can start to do worse because it tries to find like little connections that aren't really there or that are just too precise to generalize to new data. All right, let's try that. No errors. No, we got a lot of warnings. We'll check the warning. Okay, note that it's still working, though it just looks bad. It says early stopping conditioned on metric val loss, which is not available. So we'll have to look into that. Now you can see it's continuing to find gains. Like note that I'm on like over 200 epochs. So you look at how that accuracy is going up. It will eventually stop because eventually it could reach 100% accuracy and like, you know, not show improvements. But the idea here is we're finding an ideal number of epochs. Okay. If you ever find it just going on too long, you're like, okay, this is too long for me. You can always like set it lower. Now I say this is going on for a bit long because I'm wondering about the warning here, if the warning is somehow causing an issue. It's possible. I mean, it will just end on 1,000 as well. So, you know, like is it really not improving in each round? I see val loss. Now I'm a little skeptical here. I don't want to just like sit here and wait for it as we code. I think I'm gonna stop this and make a couple checks. So you can try this little stop here. It doesn't always work. Sometimes it does. If you ever want to stop something too, you can just go to runtime and interrupt execution. See that? And you're given the shortcut to it too. You know, in Collab, it shows you the shortcut there. I'm going to interrupt execution. Okay. I think that was probably, or I can even change it too. You can see that it was high, so it's doing well. The only other thing I can tell you that I do have like notes on this. There's no error, and I don't know that this matters or not. Maybe it does. It's the validation split. So a validation split is And it could be that something new just changed. Like 0.1 means that they're actually going to show you, this would have been helpful, the test score each round. If you just say, hey, I'm just going to hold back 10% of my training data and use that to actually generate a test score each round. So just train on 90% of it. So you don't necessarily have to wait till the end, which is then on a separate test set it's never seen before. And I do want to double check my code from my other computer screen. I mean, it looks pretty good. Like, I don't see, I have metrics accuracy. Like, let's read what it says. This is when I do a Stack Overflow search. But I'm just gonna I'm just gonna try a runtime restart and run all. I had an error the other day and that worked. Okay, it can happen. It can fix things. We'll just jump in Stack Overflow. Invalid syntax. I forgot a comma there. Just run this cell again. Let's see if it starts cranking out the warnings. It's possible I stopped mine prematurely. Yeah, with the validation loss, it doesn't give the warning. So again, I don't know if it's going to continue for as long as the other one did. It could have been the case that the warning, see, it actually stopped. So I think the warning was somehow preventing it. So maybe it's looking at the validation loss as the way to stop it. Let's see how we did. So got comparable to the best score before, right? We're hitting like 94%, which is pretty good because guess what? We're on a subset of the data. So all we did with this was look at making some improvements to keras to look to see, can we, like with deep learning, make some small changes and outperform, say, the XGBoost classifier and other classifiers, and we certainly did. Just a preview too. Look, this is the MN IST is images, okay? And we're not treating it like images, but we will when we shift to convolutional neural networks, which is the first big topic. We're treating this in just kind of a straightforward way right now. This could be any numerical data. So what we're doing is you're learning how to use keras for any basically numerical data with multiple outputs, okay? So keep up the good work.